Here's a graph of the exponential function y equal to 2 to the power of x. Let's take a look at the different properties of this graph. What do we notice? So one of the things we can see is that there's a y-intercept of 1. We can also see that if we zoom out, we can see there's a horizontal asymptote, which is a line that the curve approaches but never quite touches. So if we keep going to the left, the curve gets closer and closer to that line. And that line is y equal to 0. Now, what happens if we change the number 2? So suppose we use something other than 2. What if we use 3? Or 4, or 5. As you might expect, y increases more quickly when you increase the base of this power. So you can put, I'm using positive integers, but you could use any positive real number as the base to make an exponential function. So suppose instead of a value that's greater than 1, we use something between 0 and 1 as our base, for example, a half. Then we're getting a curve, which if you compare the two side by side, are actually mirror images of each other. So in this case, this exponential function is decreasing. And that makes sense. If you raise a half to a higher and higher power, it should get smaller and smaller and smaller. And once again, it approaches the x-axis, which is the line y equal to 0. And again, it has the same horizontal asymptote. It also has the same y-intercept.